This is what goes on a speedcuber's head while solving a 4x4. So first thing you need to know, this is not a tutorial, so don't expect me to teach you anything. And then next thing you need to know, there are 6 faces: left, right, up, down, front, back. The next thing, corners, edges, centers. That's all you need to know. And another thing you need to know, actually I lied, is I solve on orange cross. So that means orange on the bottom. Instead of white, like I've been demonstrating, I solve it orange. So yeah, orange. So anyway, I use this method for 4x4 called the Yao method because I'm a speedcuber and all good speedcubers use that method. For 4x4 at least. And it starts off with a weird step where you solve a center here and then a center here. They're opposite of each other, so that's really nice. And then the next step is I solve the orange cross before solving anything else. Like here, there's an orange cross, so I just solve it. So I make some edges and then I solve them like that. And then here's another one, but I actually don't put that there. Instead, I attach it to a bar that's the same color, like here's green and here's green, so I attach them. Now because these are all green, I have to make a green center. So I attach it to a green center. Then next I make all the rest of them. And yeah, here are all the centers, and then here are a bunch of cross edges. So now I finish up the cross, and there's a cross. See how similar they look? They're awesome. Anyway, that's the first step, basically split into like 50 different steps, but that's how this method works. Next thing is to solve all these edges that are not correct. So I do this thing where I do that ahead of time. Then, because I see this and this, well, they're already there, but like if I slice it and then these are here and I slice it back, it'll be solved. So I do the same thing. I take this edge, look for one the same color. This is yellow and blue, so here's a yellow and blue one right here. I put it next to it, so when I slice it back, it's going to be solved. Then I do the same thing, and then, ooh, I got lucky. Now I have a bunch of solved edges. So, I do this weird thing, actually, where I take an edge that's not solved and I just slam it there. And then I put another one, and I connect them. And then I look at the one here and connect that, then solve it. And now I solved 2 more edges, and now there are only 2 left. So I just go ahead and solve those. And now all the edges are done, yay, with the cross. So I don't have to look for anything like another method called reduction, but no one ever uses reduction for 4x4. Everyone uses Yao, so that's great. So that's why I'm kind of teaching this, not really though, because this is not a tutorial. Next thing you do is solve the first 3 layers. Ooh, yeah, 3 layers. Like this. This is actually, basically it's the first 2 layers, but it's 3 layers because it's not 3. It's 2. But it's actually 3. So, yeah, I just do the same thing. And now there's the first 3 layers. And then next, I solve the last layer. Except this is weird because there are only 3 correct edges. Usually there can only be 4 or 2 or 0, but there's 3. So there's a special 4x4 algorithm. I use one that looks like this because it's kind of cool. And you can see that this algorithm is special for 4x4 because you split it in half. But 3x3 you can't split in half because that's not how 3x3 works. That's why it's only for 4x4. And then that usually fixes the problem. Then I just do that thing I do for 3x3, and then oh my gosh, there's another problem. If you don't solve Rubik's Cubes, you probably can't see this, but there is a problem, and that's another thing. Problems in 4x4 and above are actually called parity, and this is parity. Except it's for this specific step, which is similar to the last step in solving a 3x3 using CFOP. It's called PLL, so this is called PLL parity. The other one was OLL parity, now there's PLL parity, yay. And there's another algorithm. It looks like that. And you can see that it doesn't work for 3x3 because there's only one center slice thing. But here, there's 2. There's this one, and there's this one. So that's why this is only for 4x4. Then I just do the rest like a normal 3x3 algorithm, and it works. That's what basically goes on in the method. And now I'll kind of try to demonstrate how I would think through this. But because I'm actually fast, I don't actually think by words, but I'll try my best. So first I'll plan out the entire first center, and then I'll kind of plan out the other center, but I'm kind of not smart enough to do that. So yeah. Anyway, I solved the thingamabobs. And now next I see these two, so I'm going to connect them. And then I see these two, so I'm going to connect them. Sorry if you can't see, I'm kind of going fast. I see these two, I connect them. And then I see the last two, I connect them. I see a bar here, I connect those. And then I make a center. Now I decide to make all the rest of the centers because that's how I roll. And then I connect the cross, and now there's the cross and all that stuff. So now I decide to do the edges. And yeah. Now I have all the edges. And now I see this thing, it goes in here, so I just did that. I see this needs to go in here, so I do that. I see these two pieces, it goes right here, so I solve that. Then finally these two, I solve that. And look, it's not messed up, so that's great. So I can just do the algorithm. And then this one's messed up, so I have to do the special algorithm. And then now it's not messed up, so now I can just solve it. And that's basically how we think. So yeah, except we usually don't think in words, but that's just how this works, so have fun.